Weather Lesson 5, Predicting the Weather. The first step in forecasting the weather is to collect data. We collect data through either directly observing what's happening in the atmosphere outdoors or through the use of instruments. The picture here shows a number of those instruments, including an anemometer, a barometer, and also temperature gauges. Meteorologists are scientists who study the weather, and they try to predict what's going to occur in a location based on what's happening in other locations. Meteorologists use maps, charts, computers, and other technologies to analyze weather data and to prepare future weather forecasts. The techniques for predicting weather have changed dramatically over the last 2 decades, along with the technologies that we use to predict weather. Short-range forecasts have become very accurate. Those forecasts from 3 to 5 days out are extremely accurate, especially in areas outside of Michigan. Remember, Michigan has a totally another dynamic going on with the Great Lakes. That adds a little bit more complexity to trying to predict the weather. Long-range forecasts are also fairly accurate, and this has been because of the ability of computers to quickly quantify data. So we've created models, and those models help us to quantify data and calculate data in order to predict what may occur in the atmosphere in the near future. So what can we learn from weather maps? A weather map is a snapshot of the conditions at a particular time over a large area. There are a number of different types of weather maps. These weather maps come from the Weather Service. Data from local weather stations all over the country are assembled into weather maps at the National Weather Service. One type of map that is created is called an isobar map. So on these weather maps, we see curved lines. The curved lines connect areas of similar atmospheric pressure. You'll notice there's a number of L's and H's on this map. The L's represent areas of low pressure. The H's represent areas of high pressure. The yellow lines connect areas of equal pressure. You'll also notice there's a number of yellow numbers throughout the map. Those yellow numbers are the actual atmospheric pressure readings. And again, those are collected by instruments, specifically barometers, that are found all over our country. Isotherms. An isotherm is a line that joins places that have similar temperatures. Isotherms may be labeled with the temperature in degrees Fahrenheit, degrees Celsius, or even both, like you see in this map. Also notice that this map has a number of different colors. The different colors represent the isotherms. Predicting the weather. We're going to specifically look at weather map symbols now. So weather map symbols are used to identify the various conditions occurring at locations on a map. This table shows us a number of those different symbols, and we'll talk about what they represent. On the left-hand side over here, the number represents the percentage of cloud cover. There is a symbol associated with that percentage. 20 to 30% has the circle that is a quarter filled in, and a number of other symbols represent the amount of cloud cover. Obviously, a completely darkened in circle is going to represent 100% cloud cover. Wind speed, and this is measured in miles per hour in the United States. There are a number of different symbols that represent the wind speed. A straight line represents a wind speed of 1 to 2 miles per hour, whereas a symbol that has a couple of straight lines coming off of it, along with a triangle at the end, represents higher wind speeds. In this case, this symbol represents 72 to 77 miles per hour. Weather map symbols found on the weather map also have the atmospheric pressure measured in millibars. The wind direction uses the wind speed symbol, and it puts it off of the circle in the direction that the wind speed is coming from, or the wind direction is coming from. The temperature is also identified on these symbols. So let's try one. On your sheet of paper, please identify what you think the percent cloud cover is, what the temperature, the atmospheric pressure, and the wind direction is, along with the speed based on the image you see up at the top right of this slide. Newspaper weather maps. Maps in newspapers are simplified versions of maps produced by the National Weather Service. You've probably seen these maps numerous times. Standard symbols on weather maps show fronts, areas of high and low pressure, types of precipitation, and also temperatures. Note that the high and low temperatures are given in degrees Fahrenheit instead of degrees Celsius. In the United States, we tend to like degrees Fahrenheit instead of degrees Celsius. We understand degrees Fahrenheit a little better than we do degrees Celsius. Here's another picture of a weather map. A L represents an area of low pressure, and H represents an area of high pressure. Many weather maps are color-coded, indicating temperature. A line with jagged triangles off of it represents a cold front, whereas a line with a half circle on it represents a warm front. Weather maps may show fronts, high and low pressure areas, high and low temperature readings for different cities, precipitation, and the color bands may indicate differences in temperature. Some weather maps also indicate whether there's precipitation and the type of precipitation. So over here, this would represent snowfall, whereas down here it would represent rainfall. This is another weather map. Notice the different front lines that you see here. A cold front is represented by usually a blue line, and that line has triangles off of it indicating the direction of that front's movement, or that air mass's movement. A warm front is indicated by half circles, and again the direction that the half circles are pointed represents the direction in which the front or the air mass is moving. A stationary front has alternating bands of half circles and triangles, and they are in opposite directions of one another, indicating that one may be moving in one direction, but the other one is counteracting it, so that front is not moving. An occluded front usually is a different color. In this case it's purple, and you'll notice there's an alternating band of triangles and half circles, and they face in the same direction. Also notice here that there are isobars, areas of pressure, and you can also see some of the weather map symbols here that give the amount of cloud cover, the wind direction and speed, along with temperature. There are limits of weather forecasts. Computers have grown more powerful, and new satellites and radar technologies have been developed, so scientists can make better forecasts using all of these tools. But even with the extremely powerful computers that we have, it's very unlikely that forecasters will ever be able to predict the weather accurately a month in advance. This has to do with the so-called butterfly effect. We know that the atmosphere works in a way that even small changes may affect the weather today, tomorrow, or even further outside of a week in advance. The name refers to a scientist's suggestion that even the flapping of a butterfly's wings can cause tiny disturbances in the atmosphere. So a tiny event might cause a larger disturbance that could eventually grow into a large storm. We are just unable to predict all of the variables that could cause atmospheric changes and lead to weather condition changes that may produce storms in the future.